Hi, folks. Welcome to the Breaking. My name's Henry, and today we're going to be geeking out in the analog domain. That's right. We are going to look at a composite mod for the TRS-80 color computer. Now, there have been so many people who have put together so many composite mods over the course of time that it's not even funny. So ultimately, there's not much new here if I were just to go ahead and solder it together, plug it in, and Bob's your uncle, there you go. Instead, I'm going to guide y'all through the process of me wrapping my brain around reverse engineering a PC board that doesn't have an attached schematic to come along with. It might just be fun. All right, so here is the PC board in question. Now, this is a very simple build. If I pull up the bill of materials, it is along the lines of, you can look at this and see that we've got the parts list, very simple, just a few resistors, a few capacitors, a couple of 2N2222s, and a 2N3904. Now, I want to bring something to everybody's attention. This right here, that 2N2222, that's where my brain started melting. That was the first step. Because as it turns out, when you're dealing with a TO92 package, there is no such thing as a standard in-out. And the other problem is that the original 2N2222, and when you try to look at 2N2222, you run into this, the pinout described is for a TO18 metal can package. Now, that would be wonderful if the TO18 metal can package was still produced, and it'd be great because that metal can gives us better thermal conduct, but it's not made anymore. I'm looking at a TO92 package, and I'm looking at something that says, oh, I've got a pin 1 over here or something like that. I don't necessarily know what that pin actually is. Is this supposed to be the collector? Is it supposed to be the emitter? Normally, the base is in the middle, and from what I can see here, looking at this, I've got yellow going. Yellow is an input feed of some sort, if I recall correctly, from the Mark Data Products information. Let me go ahead and pull that over here. Yeah, yellow is our luminance input, and red is plus 5 volt power, and green chroma. Getting over here, green and yellow, and then red the plus 5 volts. And those are all going to the center, which would indicate base. All right, wonderful. Now, the 2N2222 is an NPN transistor, and I'm going to assume that it's not working in an inverse mode, which means that the collector should be at a higher, am I looking at that right? The collector should be at a higher potential than the emitter. In our normal way of doing things, you generally have on American 2N2222s and on the majority of 3904s, which T2 is a 3904, it's going to be emitter on this one, base, and then collector. That should be it. And if this is the emitter, it should be at ground potential. Or it should be, no, if this is the emitter, it should be at a lower potential than the collector, and the collector should be feeding off the 5 volts. And as we saw earlier, 5 volts is our red input. So we've got 5 volts coming over here. Everything in my brain says that this should be the collector. And it confused the snot out of me because this has like the N1 marking, and this has the Pen 1 marking as well. And this is tied into the bases of, through a resistor network, the bases of these two, which would tend to indicate that this is at a lower potential than it is at the collector, although the base is also set through the resistor at plus 5 volts. Oh, goodness, what is going on here? All right, not sure. Let's just go ahead and see what we can do about putting this thing together and seeing if it works. Now, I am thoroughly unfamiliar with doing much with bipolar junction transistors other than using them as very simple inverting buffers or switches or something like that. I can probably wire together a NAND without that much of a problem. I know if you take an NPN transistor and you put the collector at a high voltage and you put the emitter at a low voltage, and if you put the base something close to the high voltage, then it's going to turn on and allow current to flow. That's about the most I know. And I know if you play around with this a little bit, modulated in between the low rail and the high rail, you get some amplification happening through, current manipulation or something silly like that. It never really made much sense to me when I was studying this because it's a current-based device, not a volt. My poor brain still doesn't get much more than electron flow when it comes to stuff like this happening. And a lot of what's going on in here is kind of black magic. But a schematic helps me work things out. So I'm going to all right. So first thing that's driving me a little bit back crap is what's going on with these transistors. So you see that this red is going to be a plus 5 volts. So let me go ahead and get a plus 5 volt up here real quick. Plus 5 volts is feeding directly into the emitter of, or into the collector of a 3904. So let me find a 3904. So if I look at this, I can see that I'm going to assume that those are the collectors. So let me go ahead and add in the 2222s. So what's happening with this emitter side here, paralleling out to these resistors here, which are then feeding into the bases of these two, do what looks like a provision of some kind of biasing or balancing. I don't know what's going on here. But these two, also the emitters on these need to hit the ground rail, but they need to hit the ground rail through resistors and some capacitors. So let's get that worked out real quick. There we go. And that's confusing as all get out, but hey, at least I've kind of got something that makes a little bit more sense as far as that goes. That is now coming off of that network is going to ground. There's no outputs, anything other than ground onto that. Those are taken care of. So now the bases of these, both of these, are fed through a resistor network. Now, here's where things get interesting, because this must be no. This has got to be some kind of biasing this, because now it's receiving an AC signal on the base. Is it? Oh, because these are just the collectors. And what we're doing is we're biasing. That's the only thing that can be happening there. We've got to be biasing space. That's the only thing that makes sense. Okay. So this is the input. This must be buffering or biasing or balancing or something. Okay, so this is our input, which is coming off of a pair of capacitors. We've got a C2 and a C1 and a C2. Those capacitors are both 1 mic, and they're coming off what is going to be luma and chroma. I think it's going to be luma and chroma. Yellow is luma and green is chroma. All right, so I'm going to make these labels. What's this emitter run off to? This emitter now runs off to what looks like a set of biasing circuits. And so it runs off to R5. I'm going to get this. So off this emitter, I immediately go into 2 resistors, R3 and R6. R3 and R6 are both 200K, 200K, but 220 will. Okay. I'm going to go ahead and put those at 220. That one. Is this connected to anything else? I think that terminates everything there. So I don't even know what the function of this is here. The only thing I can figure is that it's some kind of buffer balancer. It's also taking, oh no, that's not any type of output over there. That's coming in over here, and that's coming over. It's got to be some kind of. It's analog black magic dealing with bipolar junction transistor. But this has got to be doing something as managing, balancing, and chroma signal. So the luma and chroma, though, eventually they need to come. Oh, I missed something very important here. I did miss something very important. This is actually doing the balancing because it also ties in to a couple of other places here. Through resistor 4, it ties to R4, it ties to ground. And this is my emitter output. So I need, what's R4? R4 is 2.2K. So I can grab one of these. That's R4 to ground. Yep, that's R4 to ground. And then it's R5 to the video out. Okay. I don't understand this, but it's like, okay, I think I can kind of sort of trace where the electrons are going. This is confusing. This is combining, okay, it's combining the chroma and luma into a single signal through this transistor and spitting out here. But why this is doing funky things about like this is biased plus ah! I, I don't get it. I don't understand, but the two signals are happening there. Okay. Great. Wonderful. Lovely. All right. What am I forgetting to do here? What networks am I forgetting? Now that's already tied to ground. This is a tie to ground. Audio. Okay. All right. So black. If I recall, let's see. Black is a simple audio input, right? Yes. Black is audio input. This is simple. All we're doing is we're going to route it through center, and then that's going to. Why does that need to couple to ground? Okay, it's just coupling over to ground to a capacitor. C5 is 22 nanofarads. So in other words, we're just kind of getting like the ridiculously. It's acting like a high pass filter. Okay, that makes sense. Now, audio in goes through that, cap, ground, that, easy enough. This still breaks my brain. This really does break my brain. I, all right. Go away. I'm thinking voltages. I'm not thinking currents and AC signals. The two don't really mix when it comes to this kind of thing. Okay. But I think this is happening. Okay. I don't get it. I don't quite understand it, but it's breaking my brain less because we can't pull an output off the collector. Okay, so we're pulling an output off the collector, and the collector can be tied to, on an NPN, can be tied to VCC through the appropriate resistor, collector resistor, which is happening. All right, we're good. I think this might be correct. Maybe. horizontal. Yeah, I'm going to go with that footprint for the, okay. Here, working on it to try and match everything up. Now this all makes sense. All right, so the positive, all right. So it looks to me like everything is more or less in the appropriate places. Some of this is going to be a little bit of a pain to route, but that's okay. And it looks like everything connects up the way that it should. Now, I did this just to basically make sure that everything looks right from this to this, and it looks right from that to that. So with that said, I'm at a point where I can go ahead and follow this. You know, it makes a bit more sense to me now. I understand a bit more what's going on. I can go ahead and start fabricating some of the stuff I need to fabricate for that. But that's going to be I'm taking a break, and I'm going to do that later. It shouldn't take that terribly long to put together, but this is good where it is. I've tested this before, so I know this works. But just to be on the safe side, I'm going to go ahead and get my handy-dandy battery-powered, it accepts RF inputs monitor thing and plug it in. Yes, you get to see my bowl, Kate. Is that not a pleasant thing to behold? And I've got basic. And so let's go ahead and do the quick 10 print thing. Oh, well, I just abbreviated world. All right, cool. I'm good with that. Good. And that works, so I can go ahead and shut this down. Unplug that. There we go. And now we just need to get this little bad boy open right on up. Personally, I look at this and say that this is physically isolated enough that it's not going to be that big of a deal, but I'm not going to play that game. And right here is what sold me on this little machine is XC80652P. That spells T1. All right, so we're going to need to open up. Hang on, let me look at this real quick, because this has. That's the D&E board. That's ET board. Okay, you are right. Okay, so this is the Korean, I think, and that is the first pin up. There's nothing there. What is that? Oh, I need to look at that thing again. Water 1, 2. Okay, red. Okay, so that's red is +5. I've set blue to ground. It says silver, aluminum, sodium, and chroma. All right. So I'm looking at this. All I need here is the +5. That's all I'm looking for. The joystick connectors, and I don't see anything that's obviously a +5, but I know I can catch it on here. All right, so I want to make sure I know what that is. All right, so that is pin 1. That's pin 1. Luma is coming off of pin 28. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I should have thought about that because this is supposed to be a pin for pin drop-in replacement for the original VDG. Okay, so that's going to be pin 28. 21, 2, 3, 4, 5, 6, 7, 8. Good. Let's take a look at this and see what we get. I have nothing on the composite box. Absolutely nothing. On the upside, though, it doesn't seem to have disturbed the functioning of the RF out. And quite frankly, with the RF out working, I am less concerned about this as far as this working, because this is janky. This is really janky right here. And I mean, I can go through and diagnose and see if I've got power or anything like that. But I'm going to call it right here for this. Ultimately, like I said, the composite mod is not as important to me. Okay, so that was less than wonderful but I'll tell you what, I really think that what the problem was isn't with the circuit itself. It's with the fact that my breadboarding is actually quite janky. I've already pulled off all the little things, and you saw how janky it was putting it together. And so what I'm going to do is I'm going to complete the PC board. Get that design done. Yes, I know there's already a PC board design there. Yes, I know I could just go ahead and duplicate that. I'm doing this I'm doing this mainly for the reverse engineering of it and to get it working, because quite frankly, this has really good RF output, and I've got a really good little monitor that takes care of it for me. So I'll get that designed. We'll get that off to a provider, get those printed up, get it on back here, get it put together, and see what happens. And the other reason that I want to do a custom PC board instead of using the Mark Data Products one is because, believe it or not, this, which you can't really see very well, is this little TRRS connector. There we go. There, now you can kind of see what's going on with it. This little TRRS connector is actually a really convenient thing, because you've got your AV cables that end in a TRRS connector right there. So rather than trying to hunt down a bunch of things or something like that and find room for a couple of RCA jacks, if I'm going to permanently replace, which I've done in one of my other machines with a different composite mod, if I'm going to go ahead and replace the RF modulator with a composite board, then rather than having to drill a new hole or anything like that, I can just go ahead and replace. Instead of having two RCA jacks, I can have one TRRS jack, and that'll take care of the problem. No issues there. All right, so I'm not going to call this a success. I'm going to call this a learning experience. I'm not going to call it a failure either. It's a learning experience. Doesn't keep it from being frustrating. At any rate, I enjoyed doing this, and I enjoyed going through the schematic and the reverse engineering. And quite frankly, I hope you got something out of it too. If you did, great. If you didn't, well, the comments are there below. And if you liked it, like it. If you disliked it, dislike it. That's fine. But whatever the case, I hope to see you. I hope to see you again soon, right here at the break key, where hopefully next time I will deploy marbles in a more organized fashion. Have a great day, folks. Like, share, subscribe.